Hey, welcome to Build 2, where we go into more detail, the background behind the scenes stuff that didn't make it into the more popular Quint Builds channel video. We're talking about the, let's see, this is part 2 of my wind power on a Camry, and man, I really wanted to get the full-on mileage results into this video so we can just say, does this hurt the mileage, and how badly does this improve the mileage, and how much, or is it just a net like Unity kind of thing where there's no improvement? But as you can see in the video, it was just, the months just cranked by, so much going into this, so many failures. Like, all right, I've got enough content. This is more than enough to make a legit video that people can get really engaged in and learn some stuff about wind power, electronics, mechanical, all that stuff. First things first, I want to address the safety. I know we had some detonations there on the road. Those were plastic turbines. I mean, you could hear the pieces kind of just bouncing off the car, and there was not even any chipped paint on my car as those pieces are coming flying off. So they're breaking into tiny little pieces. They're not going very far. Also, anytime that we were generating any decent amount of power, or those, any risk of an overspeed condition, I was looking in the rearview mirror, looking way down the road, and making sure that, okay, we're not even going to pull onto the road until we see a large gap that we can be driving. So rest assured, and you can see in any of those shots where we had stuff rupturing, there weren't any cars around us. So regardless, don't try this stuff at home. I've got the 3D printers that I'm using with that resin for the blades is incredibly strong. I've done a tensile, did a video on tensile testing 3D prints, and that Formlabs resin just kicked everything, even professional grade printers, to the curb. It is so impressive. It's the best stuff I could possibly be using, and yeah, the other FDM style printers just aren't going to be able to hold up to it. But besides, this is really hard to do. I have semi-professional level equipment to be able to machine stuff and things. So let me take on this this experiment and show you the results, and you don't have to worry about it. I'm grateful that most of you get what I'm trying to do here, and I also get that there are viewers out there that see me putting a turbine on a car, and they just immediately jump to the conclusion that I believe I'm just gonna at some point be able to turn the engine off and just coast with zero energy, whatever, just at any speed I want to down the road. No. So you get this. This is a recovery type thing where I'm trying to eke out it. I'm trying to nail down, is there some sort of aerodynamic recovery that can happen here on the amount of energy that is being used pushing the car through the atmosphere? And if you've been watching YouTube at all, there have been a lot of videos about wind and vehicles coming out over the last couple of years. It started out with Veritasium. Actually, it didn't start out with Veritasium. It started out with me doing my videos. And then here was Veritasium did a video on that Blackbird car that was actually built before I was getting into this, but it didn't really come to a viral nature until Derek from Veritasium did a video on it. And then anyway, I'll probably scroll through a couple of different videos. But what I haven't seen so far, and the reason that I'm doing this, is I haven't seen people sharing their data. Actually, like, okay, here it is with and without the turbine, how much energy it took to push through the wind. And of course, some of those, including Derek's, they're using a turbine that is way above the car. And then there are some as well. There's a van out there putting a blade or right in front of the grill. But again, no numbers, nothing. And I get it, because you can see what I'm doing. You have to get a significant power output for it to show up as a mileage hit or improvement. So this is a very difficult thing to do. Whenever I see those videos come out of wind on a car, it's like, show me some numbers, show me the data, come on, give. And so I'm doing it. That's why I'm doing it. I want to see these numbers. I've been sent some stuff showing, well, let me talk about that. One of the things that was very interesting that happened during this filming that did make it on the main video was when that semi-truck came the opposite direction, and you can hear the turbines just, I mean, they take off. And it reminded me of the scene from Monsters, Inc., where the monsters have the little girl at home in their apartment, and she's crying and they're trying to get her to stop, and then she starts laughing, and all of a sudden all the lights just up, and I mean, it's even a similar sound to what that noise on the turbines. So it just reminded me of that. I'm not trying to say there's some infinite energy thing here available, but there is. It reminded me of the wind power equation, where the velocity of the incoming wind is cubed. And that's why, say, we were driving up until the point of that semi-truck coming the other way, the turbines were just encountering wind that was approximately whatever the speed of the car was, plus if we had a little bit of maybe 10 mile an hour oncoming wind, it might have been a little bit more than that. But essentially, the turbines were experiencing wind at the speed of our vehicle, and then here's the semi-truck coming the opposite direction at a similar speed, probably close to doubling the speed coming in, and now we do a cubed on the velocity, which we just doubled, and of course the turbines took off. So that tells me that in future testing we really need to eliminate oncoming traffic as part of the testing, even if we do go to this carbon fiber blade thing, that I either need to go drive out in the desert where there just are no cars, or do this at 2 a.m. When there are no cars around. But that definitely is, it just illuminated for sure that oncoming traffic is a factor. Now, what are my expectations for what we're going to get? I don't know. I've been sent to say, looking at that power equation, in theory, as the velocity of the car is increasing, the availability of the wind power and, of course, the drag is curving up tremendously. You say that to the cube of the velocity, while the rolling resistance of the car could be relatively flat. So there's some estimations that it's going to dramatically increase the distance that the car can go. At the same time, there's a tweet out there that a friend sent me that Elon Musk had shared, saying that it was one of these magnets on a boom in front of a car, which of course wouldn't work. The forces zero out. And Elon Musk had grabbed that and tweeted that wind power on an electric car also doesn't work. And note, he said electric car. So here with this, even if there isn't any ability to recover any aerodynamic, if it's just completely lost there from the aerodynamic drag, trying to turn that into recoverable energy for the car, even if there is nothing there, the automotive alternators are so inefficient, as the estimates are like 50 to 60%, that we may still see some small mileage improvement just from that. So I say, it's impossible for me to predict exactly, and impossible for anyone to predict exactly what's going on here, because we're not talking about a frictionless environment like a lot of physics classes, which I've taken a number of in engineering school. The problems start with assume a frictionless environment. It's like, okay, because it makes sense for that, because you're teaching you're teaching a principle, and adding friction makes things way more complicated. Friction and then adiabatic, or no heat transfer either. It makes it way easier because you just eliminate a bunch of math when you're trying to teach one particular principle. And of course, this is real world. There is friction. There's all kinds of stuff with heat transfer going on. So, but I feel like, I hope you feel like as well, that I'm building this test bed that will just say, okay, real world, everybody, I think it's gonna shut everybody down after this, right? Unless it just totally takes off and says, wow, look at the huge improvement in the mileage, and then other people will be trying to replicate the results. whatever it is, just like, okay, here was the setup, obviously put a lot of effort into it, and here were the numbers with and without the turbine, before and after, eliminating all the variables we possibly can, and you just won't see, like, this will just be the end of it going forward, that you won't see all these little models, scale model stuff and conjecture coming out, which all it does is whet my appetite to want to do it more. Something else I didn't mention in the video because it wasn't core to the story was the nose cones. Every time we had a destruction of the turbine blades, the nose cone was going with it. And I was printing those nose cones out of this really strong but also kind of brittle resin. And one of the engineers at Formlabs had told me on a call way back, he said, pick your resin around your failure mode, whatever you want your failure mode to be. And it's like, well, I don't want that to shatter. I'm going to try this from the clear resin to this tough 1500. And hey, I never had another nose cone break after that. So kind of cool how material choice there can help out dramatically. Say, not a big deal when you're 3D printing the parts, but when I have very limited time and resources to go after this, is like, yeah, I don't have to buy any more resin, and I don't have to take the time to print it and put it on there. So I thought that was kind of cool that if you go back and watch the videos, you'll see when the nose cones change from that clear material to, just like, all right, I'm just going to try this other material, and real world stuff. It's kind of cool that these will probably last for the life of the project. But let's talk about the failure. The primary failure ended up being for this project was that grinding, vibration, whatever that noise was. If you watch from the previous video where I'm putting wind power on my car, I was setting it up around a smaller generator. And when I set it on my lathe, put it on my mill, there was just no way that it was going to generate the 400, 500 watts that it was rated for. And so, I'd reached out to that seller on eBay, and of course, they're just selling whatever these generators are to people that want to do their own free energy, whatever green energy project. And it's like, hey, I get it. People advertise these generators for wind power, whatever you're doing, usually wind power. They advertise them, even the turbines, for doing a way higher number than what they can actually do. And that's so that somebody who just wants to try it out says, oh, for the same amount of money, I can get this one that says it'll give me double the power. And not knowing that it might be even worse than the other one. And there are some legit brands, I'm told, that are US-based brands that are like, hey, these are actual numbers that we're getting. And I bit on these ones because they had graphs there, and then I try them out when I get them home, and they're not putting out what they're supposed to. So this one claims to be a 1200 watt generator, and they put free energy right on there. It's kind of silly. But claims to be 1200 watt, and I was getting, maybe it will, but I put this thing on my milling machine in the first video and put the nut here on the threads, put a socket in the quill of the mill, and cranked this thing up. I forget what the RPM that I was at, but it's probably like 1500 RPM, and got I was getting 9 amps out of it at like 50 volts. So it was like really close, like 500 watts that I was able to get out of it. So the generator is capable of generating that kind of power. But again, I was doing it with a socket, like an impact socket that I had, driving directly on this nut. And the shaft is smooth. Now, they tell you to rotate, if you're going to drive this thing, drive it in a direction that the friction with the nut will help tighten it up. And we're doing that. We're tightening that thing. But I tend to think, set that down, I tend to think that the noise that we were getting, because it had this vibration associated with it, that it wasn't the turbines just going faster, that it wasn't the DC to DC voltage converters that were that were somehow just like, oh, we're maxing out at the current limit, that it wasn't that it actually was a mechanical thing of the pulley slipping on this shaft. Do I have it sitting here somewhere? Anyway, the pulley was slipping on here. And so in order to fix that, I've got to do some kind of a clamping thing or really just keying it, putting a key in the shaft. But in order to machine that, I've got to take this thing apart. I'm not super confident that, like there's going to be spring-loaded brushes in the back that I've got to be able to, like, maybe they have special tooling at the factory. I don't want to have to make that stuff, but that's probably what I'm going to end up doing as the next step, is to key the shafts on these things. I also may, in order to test and validate that those two DC to DC converters, voltage converter modules that are in the car that are taking this 50 volts and turning it down to the 12 to 14 for the car, to verify that they're actually doing what they're supposed to do, I would have used my bench power supply right there, but it can only go up to 30 volts and 5 amps. So let's see, 3 times 5 is 15, so 150 watts. I'm not going to, I need to get the like 10 amps at 40 or 50 volts. I mean, maybe I could do, if I bought a second one of these and put them in series with each other or in parallel to try to get the amps up to where they're supposed to be, then maybe I could verify it. But really, the only power source that I have that can generate that would be to put one of these things back on the mill and run wires from it all the way out. Just have my car idling in front of the shop. I can totally do that. And that way I can be, okay, crank up the mill, get the thing cranking out the power that it's supposed to do, and then be able to sit there and tune and watch the amount of power that's coming out of the battery, monitor it like I can't do when I'm going 60 miles an hour down the road. So that'll be probably the first step of the next video on this, and hopefully the final video on this. And of course that takes some investment and some effort to go do that, which is why I threw out the thing about the money there towards the end of the video of, yeah, this stuff is expensive. The ad revenue isn't even paying, it's like $300 or something in ad revenue. It doesn't even cover the cost of these generators. I went to a big creator event last summer down in San Francisco at my own expense, actually. And I had this impression that, big YouTubers are just able to sit back and have the money rolling in, and that is not the case. Everybody I talk to that is a creator, even with the big channels, they are striving and talking shop about, hey, what are you doing to try to, okay, what kind of levers and switches can you pull to be able to maximize what you're getting out of your channel, to be able to afford to make more content. I mean, even Mark Rober has said in one of the podcast interviews that he was on that the YouTube is a loss leader for him now, and that Crunch Labs is really what's funding things, and YouTube just helps him keep generating content and getting more views and bringing people over to the Crunch Labs. But he's running a huge team to be able to do that. Bottom line, you have to work really hard to be able to stay in this business, which is why I'm taking the rest of this video talking about all this behind the scenes stuff with this latest wind power video and making it patron only. As a bonus, I'm also going to talk about a little side project I've been working on with my whole family that's going to be showing up at OpenSauce this year. I'll also talk about what it was like to meet some of these more famous creators, Mark Rober, Colin Furze, those folks, and some comments about my knife throwing machine. So whether you're a patron of the channel or not, thank you so much for watching, and I'll see the patrons on Patreon.